प्यारे बच्चों, today we will start oscillators, that is signal generators. Signal generators are, first thing is classification. On the basis of signal, this is classified into two categories. One is sinusoidal and another is non-sinusoidal. Obviously, in this category, we have a sinusoidal signal, and in this, we have square wave, triangular, or pulse. So, we can use like this, or triangular shape. So, basically, there are two types of oscillators, sinusoidal and non-sinusoidal. Again, sinusoidal is classified into three categories: RC, LC, and crystal. So there are basically three categories: RC, LC, and crystal. This classification of sinusoidal oscillators is based on feedback network. Feedback network is a combination of R and C, then this is the RC. If feedback network is a combination of L and C, this is LC. If we are using crystal, then this is the crystal. Again, there are two types in RC. So for RC oscillators, basically you have RC phase shift, oscillators, and another one is the vintage. And in this group, so in first group, that is RC oscillators, you have to study two types of RC oscillators. First one is the RC phase shift oscillators, second one is the Wien bridge oscillator. And in LC oscillators, we have three categories. One is Hartley, Colbert, and Clamp. So you can say A, B, C. So there are three types: Hartley, Colpitts and Clamp. So this is the LC oscillator. So now we are starting basic principle. What is the basic principle of oscillators? So and this is also called Barkhausen criterion. And to understand the basic principle, first you have to see there are two types of feedback networks. Suppose here we are using a sum with negative feedback. Here input is given and this is the suppose error signal, here plus minus. Basic amplifier, feedback and output. So another group is, suppose we are using positive feedback, then what will happen? Here is input and we are using positive feedback. Then what is the difference between two types of feedback? For negative feedback, obviously you can see this output upon input is given by A upon 1 plus A. For negative feedback. How? Actually, this is the output. Then you can say error signal is nothing but, suppose we are using feedback factor beta and basic amplifier gain is A, then error signal can be written as input minus feedback signal. So feedback is the beta times of B naught. So this is the, and you can also write this is A. This signal is simply output upon A, because from here you can say output is input into A. So you can write error is output upon equals V in minus beta B naught. So from here you can find out this ratio, output upon input. Output upon input is given by A upon 1 plus A beta for negative feedback. This is the negative feedback. This is used in amplifiers. Suppose we are using positive feedback, then what will happen? For positive feedback, this ratio comes out to be A upon 1 minus A beta. And for a particular condition, suppose A beta equals 1, then what will happen? So if A beta is 1, then this is A upon 0. And for this condition means you have a finite output for 0 input. Means if we remove this, suppose this signal is not present, input is removed, and only a part of output is fed back to the input with proper sign here, positive, means both are in same phase. Then this circuit provides output for 0 input, means this circuit works as signal generator or generator. So two conditions are there. First thing is this in feedback signal must be in same phase. Here both are in same phase. One thing. Second thing is this product means magnitude of A beta. If these two conditions are satisfied, if magnitude of A beta is 1, and this is the first condition, and second condition is total phase shift around the closed loop must be 0 degree or 360 degree or any multiple of this. So these two conditions are important for this circuit to work as generator, and these two conditions are called Barkhausen criterion. If we are using positive feedback, means input and feedback signal are in same phase, and loop gain means product of basic amplifier and feedback factor. This is the gain of basic amplifier, this is the feedback factor beta. Product of this is 1, and total phase shift. Suppose basic amplifier provides 180 degree phase shift. What will happen? Then to become total phase shift 360, this feedback network must provide further 180 degree shift. So this is the basic concept, and these two conditions are called Barkhausen criterion. Magnitude of loop gain is unity, and total phase shift around the closed loop is 0 degree or 360, and this is the basic condition to work as signal generator. Now suppose input is 0, then initiation is obtained from noise signal. Noise present in amplifier. So noise signal is present in basic amplifier. This signal is amplified and feedback, and only this feedback network is a frequency selective device. This selects a particular frequency signal and amplifies. So this is the basic principle. Main thing is, suppose productive unity, one thing, what is meaning of this? Suppose this basic amplifier amplifies the signal, then same attenuation must be there by this feedback network to become product unity. This is the first condition. And secondly, total phase shift around the loop is 0 degree or 360, means if this provides 180 degree phase shift, suppose here is a sinusoidal signal, this is inverted by 180 degree, then further 180 degree phase shift is provided here to get in same phase. So this is the concept. And if suppose here signal is not inverted, then what will? So this feedback network must provide total 360 degree phase shift or 0 degree. Then you will get in same phase. So these are two major conditions. So signal must be in same phase and product is U. Now RC oscillators. You can draw two circuits. So RC phase shift oscillators. First we will discuss RC phase shift oscillator. Phase shift oscillator. So now we can draw a circuit. RC phase shift oscillator, we are using an amplifier as common amplifier. This is supply is there. This is RC or E emitter resistance, and two other resistances are there. Here is output through capacitor. Suppose this capacitor is C0. Here we are getting output. Supply is there. Suppose VCC is the supply, and coupling capacitor here at input is CI. After that, main thing is you can get here one more capacitor as bypass capacitor, and main thing is feedback. Feedback network is the phase shifter. You will have a RC phase shifter. Here capacitor, resistor, capacitor, resistor, capacitor, resistor. So this is a phase shifter. This is grounded. This is a combination of RC network, and this is connected to output. So this is the circuit of RC phase shift oscillator. Using common emitter amplifier. So main part of this is this phase shifter. This is the feedback network. Here total phase shift around the closed loop, two conditions are there. First thing is magnitude of this must be unity, and total phase shift is equal to 0 degree or 360. These are two basic conditions called Barkhausen criterion. These two conditions must be satisfied for this circuit to work as an oscillator. So what happens here? This provides phase shift. Suppose here input is like this and this is inverted. Then further 180 degree phase shift is provided by this phase shifter. This is a combination. Actually this is designed to provide 60 degree phase shift by this combination, then further 60 degree shift by this combination, then further 60 degree shift by this combination. So total phase shift provided is 180. So this is the basic concept, because we can select values of resistance and capacitor according to required safety. So, and this phase shifter is designed to provide 60 degree phase shift by one RC network. So one RC network provides 60 degree, further RC network provides next 60 degree, and last one provides next 60 degree. So total phase shift provided is 180. So this is the circuit of RC phase shift oscillator. Another circuit is used by operational amplifier. Another is the op-amp. Next is the RC phase shift oscillator. Using operational amplifier. So first see the circuit. Here basic amplifier is the operational amplifier in inverting configuration. There are two inputs. Non-inverting is grounded, and here at inverting input we are providing input. So this is the circuit. This is R1, R2. This is out. And feedback network is same. We have 3 steps. First, capacitor, resistor, then capacitor, resistor, capacitor, resistor. And this is the grounded. C, R, C, R, C, R. And this is connected to power. So this is the circuit. Circuit of RC phase shift oscillator using operational. Concept is same because here we are using inverting op-amp because input is applied at the inverting. So obviously this phase shift is provided 180 degree by this op-amp. So op-amp provides 180 degree phase shift, and further 180 degree phase shift is required to get in the same phase. So this further 180 degree phase shift is provided by this RC phase shift. One combination of RC provides 60 degree, then further 60 degree by next step, and last 60 degree by last step. So total phase shift provided by this is 180. So these are two circuits for RC phase shift oscillators, and on next turn we will derive frequency of oscillation for these circuits. How can we calculate frequency of oscillation, and what is the condition on gain of this amplifier, because conditions are very important. One thing is this, and phase of this is 0 degree or 360. Total phase shift around the globe. So keeping in view of these two conditions, we will derive frequency of oscillation for RC phase shift oscillators. Okay, this is all about for today. Thank you.